we need to analyze the truss to know the support reactions and internal force in the members of truss. There are two ways to analyze a truss. They are method of joints and method of sections. Let us learn about the method of joints and the steps to be followed. Consider a simple plain truss. As we can see, it has many joints and members. We'll name them to understand in a better way. In method of joints, the first step is to know whether the truss is statically determinate or indeterminate. If it is statically determinate, you can move to the step 2. In step 2, we'll consider the free body diagram of the entire truss without internal members. Through this free body diagram, we can find the reaction forces at the extreme ends. After these two steps, we'll start our analysis. We'll consider each joint and write the free body diagram. It's like writing a free body diagram of a particle. We have to choose a joint where the maximum number of unknown forces are 2, because we have only 2 equilibrium equations for the concurrent forces too. After we select a joint, we can use the equilibrium equations sigma fx is equal to 0, sigma fy is equal to 0 to know the unknown forces. As a general rule, we'll write the forces as acting away from the joint. It denotes that the joint is under tension. After the calculation of the forces, if the answer is negative, you should change the direction of the force and denote it as a compressive force acting towards the joint. Once we find all the unknown forces at joint 1, we'll use the results to find the unknown forces at the next joint, because the forces acting at joint 1 will have some effect on adjacent joint. If you write the free body diagram of adjacent joint, there will be a force which is common for joint 1 and joint 2. As you have already found the value of that force, it will be easier to find other unknown forces. So, we have to move from joint to joint and find the forces at all the joints. In the end, we'll have the values of support reactions and the internal forces. We can tabulate these results for further analysis. This is all about the analysis of truss through the method of joints. Now, we'll learn about the analysis by the method of sections. The method of sections is a process used to solve for the unknown forces acting on the members of a truss. The method involves breaking the truss into individual sections and analyzing each section as a separate rigid body. The method of section is usually the fastest and easiest way to determine the unknown forces acting in a specific member of the truss. Trusses are 2 force members. The forces act at either end of the members. We need to find the reaction forces by considering the entire truss as a rigid body without any internal members. Next, you will imagine cutting your truss into 2 separate sections. The cut should travel through the members that you are trying to solve for the forces. It should cut through maximum of 3 members, and it should not be cut through any joint. Next, you will draw a free body diagram for one section and write down all the forces. The forces acting at the cut section should be properly marked. Now, write the equilibrium equations of the section. The equation you can use are sigma fx is equal to 0, sigma fy is equal to 0, and sigma ma is equal to 0. Finally, solve for the unknown forces. Through this method, you can find the forces in a particular internal member easily. This is all about the method of sections. To sum up, in this video, we learned the method of joints, where you have to consider every point and progress from point to know the unknown forces. After that, we learned about the method of sections, where we consider a cut section of the truss to find the unknown forces. This is the end of Module 3, Support Reactions and Trusses. As this module is problem-oriented, solve as many problems as possible to master the concepts and explore our other courses and continue immersive learning experience.